Hello and welcome to the first video involved with formal charge, which is really critical knowledge for organic chemistry, and so I'm covering it as the very first thing. Here we have the molecule methane, and formal charge, if we're looking at the carbon atom, we look at the periodic table. So these are columns in the periodic table. Carbon is in column 4, sometimes Roman numeral 4. That tells us that the carbon is +4, and we count electrons around it for formal charge. +4 minus 1, 2, 3, 4 electrons is 0 formal charge for the carbon in methane. Of course, we are reminded that each of these covalent bonds consists of 2 electrons, and we're reminded that the octet rule is satisfied here because it has 8 electrons, 2, 4, 6, 8. But notice in formal charge counting, we're only counting the electrons closest in to the carbon, 1, 2, 3, 4. To satisfy the octet rule, oxygen in water needs 2 lone pairs. With these 2 electrons here, we count for formal charge +6 from the periodic table, minus 1, 2, 3, 4, 5, 6, 0 formal charge. Water is neutral, as we know, and of course there's these other guys there. Here we have water that would be like in an aqueous acid. It needs a lone pair to satisfy the octet rule, 2, 4, 6, 8. For formal charge, we're looking at +6 minus 1, 2, 3, 4, 5. And so we have a plus formal charge. Usually indicated like that. That's the hydronium ion, typically what is the reactive species in aqueous acids. Oxygen here needs 3 lone pairs to satisfy the octet rule. +6 minus 1, 2, 3, 4, 5, 6, 7 is a minus formal charge for hydroxide ion. So the charges here are very clearly linked to the reactivities of these molecules. Let's look at ammonia. Ammonia needs another lone pair for the octet rule. Nitrogen is in column 5. Minus 1, 2, 3, 4, 5. So ammonia has no charge. Now I've drawn these other 2 the same because there's 2 different possibilities here. If we round out the octet rule, this carbon is +4 minus 1, 2, 3, 4, 5. That's a minus formal charge, and we call that a carbanion. This carbon here, if we don't add another pair of electrons, is +4 minus 1, 2, 3, or a plus carbon. We call that a carbocation. And notice it's short an octet, but molecules, atoms in molecules can be short an octet. They just can't go over the octet. And remember, it's only limited to certain atoms, but it's actually the atoms that we use a lot in organic chemistry. Carbanions and carbocations react very differently in organic chemistry. So you can see why these are critical to be able to determine these formal charges very quickly without even doing this kind of thing, just being able to do it quickly in your head. Next up after this is going to be electron movement, as we call this system electron arrow pushing, and then resonance. And there'll be another worksheet on resonance posted on Canvas too. So that'll be our next video.